Hello and welcome back to another session of serde-yaml. It's Byron speaking. And even though I was in the middle of watching an awesome, great Jason Statham movie called Safe, I got this first issue that is not really an issue by Killer Cup. And it kind of got me all excited and stuff. And I think I would love to fix this issue myself now and have a look. So, yeah, maybe I don't jump right there. Why is this so slow? Anyway, so the cool thing is that, as usual, the good news come a bit too late to me, because I started the serde-yaml project just because I needed YAML support, and I thought, well, might as well integrate it into Serd, as I am a very Serd-based guy right now. And it's not always something I adore, just because Serd is, it works and I like the way it's done, but I don't like the dependency on Eric so much. And I think the only thing to defeat the dependency is to, well, get involved a bit more, right? That's what I do. Even though lots of the stuff that Serd does, I have no idea about yet. And the thing is that Serd, I think, is on a good path to be a bit more community-driven, because right now, if something doesn't work, you have to look in quasi-aster syntax, Serd encode, blah, blah, which is all highly undocumented code that kind of one person in this world truly understands, hopefully. And that's really the thing. It's very complex. So having something like this seems awesome. Am I logged in? Can I like this or something? Because I would certainly do everything I can do to kind of bring this up and make it a good topic. So let's have a look at the source code. And so what is this? What do I have to do with that? I think I just want to comment on this a bit on video. I was sitting on my couch, and while watching a movie, mostly I was browsing the code on my iPad and realized that I really want to browse it on my computer. And the first thing I want to do here is get a clone. Give it to me, come on. And let's have a project for this. Come on. Let's close this project. I don't know why it does that. This is new. There's some sort of bug. It shouldn't do that. So add folder, right? Add folder. Let's make a new project here. It's, what was it? yaml-rust, huh? Yeah, yaml-rust. That's the one. Save the project right away. Sublime projects. yaml-rust. The bad thing is now I have it in my recent projects list. So now I can't type YAML anymore to get to serde-yaml. Now I have to be a bit more specific about that. Very sad, but I'm willing to take this hit. Let's have a look at open just to get the basic project configuration going right away. YAML, okay, YAML should be yaml-rust now. Awesome. Edit project. And I think I will get that and then just adjust this path, which is the only interesting about this project so far. I mean, about my Sublime project, that's what I mean. Good. Do I want a linter? Let's see. Cargo build. This has no dependencies, it says. It claims. Come on. So a cargo build should just do it. It works on stable, so it claims this is stable now. Oh, that's working. And it's quite fast too, so we can afford, actually false, we can afford the linter here, which is gonna be totally awesome. And then I want 2 tabs, and for good measure, a sidebar. Awesome, and here we are. Cool, so tests and stuff, linting doesn't work there, but it totally works here, right? Yeah, I mean, not that I would need it because that code obviously is working and I don't want to modify it. But do I have another advantage through linting? I don't think so. Anyway, so yeah, if you let's look at it from a top-down perspective. And from a meta perspective, have a look at the README file. So first of all, I totally adore this project. As I said, to me it's a bit late. I think the root is a bit different. It looks at YAML CPP and lib-YAML, and they kind of are, well, I don't know, close to the reference implementation maybe. And well, what I like about this project, let's just name it. Now I have some sort of Rust-based reference, and I don't have to dig in Python code, and I can just look here, because that seems to be doing a lot already, much more than I do. It can do full serialization. And this is something or let's say, no, actually that's not something I want to look at right now. Let's look at the example here. And I think the example deserializes something from a string. Then you have a bunch of documents. In this case, it will just be one document. And then it shows off the way you access this document. And this is something I like a lot, by the way. So we remember the YAML. Can I put a label here? Something interesting that I have? Yeah, I can call it won't fix. Anyway, so as you can see here, it has a nice interface to access the string. So what I want to say, serde-JSON has a JSON document, or not a document, a JSON value it's called, which is very much the same thing. It's a possibly nested variant that can represent all the possible values of this kind of structure. So this is very nice because this allows to nicely access such a document. Right now we don't have a YAML document yet, and in one of the last sessions I was constantly claiming that I need such a YAML document. Something I also find very adorable is that the documentation is actually something that wasn't frowned upon while making this project happen, apparently. So show me the log. So Cheng Yuhang, probably I'm totally pronouncing it awfully wrong, so I apologize for that right away. Maybe Cheng, maybe Chen. Chen, I call him Chen now. So he apparently did a lot to get the documentation. Ah, damn it, I still have this cargo bug which prevents it from opening. There's a dash in there. Hatred, total hatred. So target doc, here we go. It's yaml-rust and index HTML. Thank you very much. So here we go. Let's see. Here we have the YAML enumeration. Even with an example. Let's run the tests, right? Does that work? Cargo test should work. Benchmarks I haven't seen, but it also doesn't matter, to be honest. Yeah, so this awesome YAML structure is already gonna help me. Let's refer to this maybe. This, of course, is not an actionable issue per se. I just wanted to let you know and maybe start a discussion or a grand copy event of 2015. As far as I could see, and as you know, I peeked at it already, it's very different. It's based on a reference implementation where this YAML structure here is everything. This means everything to it. So structures are first. That's how it's implemented right now, right? Structures, when you deserialize something, you get one of these structures here, which is cool, but you don't have a mapping yet to Rust-C or serd. And honestly, I think I've read this somewhere here that he mentioned Rust-C. No, sorry, here. No, wait, where? Here. So here somewhere he might have mentioned Rust-C. If I can search here at some point. Oh, come on, I didn't mean that. Just want to search Rust-C. Oh, really? Okay. So here, Rust-C decodable. So he wants to work with that, and I think it's a good idea. However, and this is kind of holding me back. This is why I used serd in the first place. Rust-C decodable does not support renaming. Right, and this is why you want to have serd. Serd can do more, and I don't know about, Rust-C decodable. I have no idea, and it looks so. It always looked a bit too intrinsic to me to really use. And I started off at Rust Decodable for Google RS, but I had to switch just because I need more features. And Rust Decodable is also nothing I probably would ever want to hack on. So Serd is the only project that kind of is an alternative to that, also in terms of feature set. Anyway, so I think that's where a big difference comes in. So the deserializer would probably then map the YAML structure that is always the basis right now to the respective to the respective Rust structure, which is always some sort of intermediate. So I think performance-wise, Serd has the potential to be better, because I'm still just in time with my implementation, even though I have to do a lot of checking for options and stuff. And maybe some of it should at some point be moving elsewhere, like in a trade. But for now, I kind of simplified everything to, or formatter, but for now I simplified everything to the point where I can work with it quite comfortably. Comfortably. What kind of difficult word that is. Yeah, so what I think is great is that I will need some sort of YAML value like this. I will just need it, and I might work differently. Where is the parser? So here somewhere there should be a load function, right? And what does it return? A result. Oh, interesting. Oh, that works with events. So is there some load that's an event receiver, parse document? How does it work again? I think maybe here in lib, is there some code here? Or some re-exports? There's some testing. YAML loader, YAML loader. I think here it might happen, huh? Load from string. Yeah, so you have a YAML loader, and then the parser, and this is where it gets the events, huh? Here's the event handling stuff. Yeah. And yeah, the thing is that this document structure is always kind of in the middle. Something I find interesting is that it's so lazy. And I don't mean this I don't think this is bad at all. It's so lazy that it stores the original strings. But it's not the original string, though. It is a heap allocated string. And even though I would be saying that, yeah, well, it's going to be interpreted in the moment you query the value, so you wouldn't really care what kind of type this is. I'm not sure if this makes a difference, you know? I think you have to parse it anyway. And in the moment you have to use a string, then you will have to heap allocate something which is slow, which is something you want to avoid at all costs. And in the moment you're parsing the token already and have the original source string, then there's no real need to have another heap allocated one. No, that's how I would think about it. Then you can as well parse it right away and prevent the heap allocation. So here I think, I don't call it a performance issue, I just say I definitely would store the actual value right away. But I would have the same ones, I guess. And the alias? Yeah, the alias is special, as this is something I also have on the list of things that I probably want to not support initially, even though it would be super interesting, at least for deserialization. I was kind of thinking that the aliases I could degenerate and put just copies there for now. So that's not a real alias, right? So how it will be interesting to see how he tackles this, even though I didn't even think about it yet. Yeah, that is that. Then what's gone? I mean, the emitter, I thought is probably interesting to look at, no matter what, because yeah, let's look at it and see what it can do and how it works. So there is a base indent. Is there some sort of option here? No. Okay. Doesn't look like it. So it seems that it creates YAML all the time. So The author, Chen, says that it's very early in the history of this project, and yeah, probably this is why it just has a very basic implementation. It kind of is hard-coded here, it seems. So there's no options for how to serialize that. But what I like about it is that it's so slim. Look at that. I mean, there's not much happening here. Why? Because actually, if you have such an intermediate YAML structure, you don't have to deal with all the stuff that I have to deal with right now, even for serialization, just to get it right. And I think also the kind of goal is different, just because I don't want to have any kind of working solution for serialization, but I want to have the solution that implements the spec to the point where you can configure it nicely. And this is something I don't see here yet for the serialization. But I think if you're going to see kind of advanced features anywhere, then it's probably going to be here, just because this already is a very clean and nice solution. And what I will find even more interesting is the deserializer, the lexer and the parser. So because that is something that makes me shit my pants. Just because I know how to technically solve that, but I'm still afraid of it. Just because it has to integrate with serde, and now that I see how much complexity is added thanks to the kind of callback style that serde works with, for good reason, by the way. How's deserialization going to work? What kind of thing will I be forced to deal with? However, that's just future. For now, I'm really happy to have the YAML structure here, which I will just look at when implementing it. Also in terms of the very nice API, I liked it. I'm not going to change it, but I'm certainly going to review it when I implement it myself. Because in order to proceed now with my stuff, I will need something like it. A YAML structure, just as an intermediate thing that keeps the value alive or keeps structured values in a generic fashion. That's the only thing that I need to take care of, and for that I will need it. Yeah, so it's going to be very interesting. Tomorrow is going to be very interesting, that's for sure. So here the parser is the next thing. Flow mapping first key. Okay, it's interesting that the first key is separate. Maybe this is required, or maybe this is kind of the standard way to deal with that, because this is, after all, based on lib-yaml and on YAML CPP or something. And these implementations are mature, and they definitely know why they did that stuff, right? And why they did it the way they did it. And by the way, the tests, they all work. So that's also very nice. This has been done in a very, very test-driven fashion. Look at that. It kind of all seems to all work. And that's awesome. This is something I would trust in. And if you look at serde, then you will see that serde projects are very sparingly tested. Sparingly. If you look at syntax, I think, just has one little example that kind of doesn't test the entire code base, and the first thing I did is run into some bug whose issue doesn't have a response, or didn't see a response in the past 10 days. So that's how serde related projects are going. You can't trust them really. They're immature, kind of, and you can be happy if it kind of works, but also it's kind of advanced stuff. And yeah, that's what I mean. If something doesn't work, which is likely because it's not really tested, then you are on your own. Then you are just on your own, and serde is too damn important right now in the Rust community to be able to afford that kind of quality. So it's great to see, long story short, to see a project here that seems to do it right when it comes to testing. So I would totally use this and would totally trust it, and would totally be happy to contribute to a project like this. Look at the documentation, by the way. Okay, here there is some documentation, because it's a very public value. Here there is less, much less, but still, something. And yeah, I mean, I have no idea. I have no idea how this parsing is really working now. But I will, once I have to implement my own lexer/parser, I will totally look at this. Apparently, it's enough once a simple peek is possible here. Oh, it's a token peeker. So okay, so oh, there's the scanner. Where's the scanner? Ah, the scanner is the lexer. I see. Oh. Look at all this code for the lexer, man. Gee, I think this is something that can totally be copied. Totally. I would review every single line, but this is something I would totally take, because the lexer is obviously a big thing, and maybe I can review it and use it. The thing is, I hate copying code, because why would you want to do this at all? If you copy the code, you can as well use the library, right? So question is, can I use, is this exported? Is the scanner usable? Yes, it is. And we have a token as expected, which is a marker and a token type. Okay, so this is how that works. And here, stream start token. Oh, look, the encoding. Okay, so only supported UTF-8. And that should be fine. I think fetch next token, fetch from start, skip stale simple keys. Wow. Unroll indent. Wow. Amazing. So this is how, this is, you know, amazing. Oh, look. No, wait. It has a reader. Okay, it has a buffer where it can peek into. Now I get it. And then it can look ahead. Okay, so this is kind of the lexer that you want to have. I see a look ahead lexer. And then you can store it into a buffer, and then you deplete the buffer first. I see. So this is always very interesting, because some lexers, they don't need a peek at all. Some need to peek a single character. And this one is made so that it can peek a bunch of characters right away. And this works by using a reader, which probably returns characters, right? Tokens, buffer, vectec. Oh, wait. Where's the structure? Here. Okay, so this works on Unicode characters right away, which is cool, because the reader just has to provide. Oh, how does that work, by the way? If you pass in a string, and if you read from that, who deals with the Unicode encoding? Who deals with UDF-8 and UDF-16 and whatnot? Right? This is something I would be interested in to learn. Because right now, the decoding of stuff, it seems to be handled by the reader just produces characters, and we would not be able to do that, huh? Not like that. So what do we take here? Wait a moment. Yeah, the cool thing could be, yeah, maybe the lexer has its own enumerations. I was just thinking we could possibly reuse the ones that we use for the presentation mode, but I don't think this is a good idea. After all, you don't have to reuse that stuff. Little tiny enums, I think we want to be as down to the point as possible. So again, here's the scanner, and we have where's the reader? The reader is T, and T is... Here's the impl somewhere. Impl. Okay, so this implements iterator. No, wait. Impl iterator. Okay, it implements... Oh. We are implementing a character iterator? Really? So we have a next here. All right. No, we implement. Now I get it. I was blind. I was totally misinterpreting this. So we are a token iterator. That makes sense. That makes total sense. And we work on iterators of type char. And this is the interesting thing. The cool thing is that way we wouldn't have to deal with the decoding thing, UTF-8, UTF-16 here at all. This is something this iterator would do, and this is something I certainly like. The question is, how does it deal with byte order marks then? I don't want to digress too much, but the implementation here, I guess I laughed this enough already. So yeah, the question is, how does the reader interface work? Maybe in the meanwhile. That was what? That was 30. All right. Yeah, maybe I'm digressing. Where's this interface now? Read. IO read works on bytes, but it has it has chars. How does chars work? Transform this read instance into an iterator over chars. This adapter will attempt to interpret the reader as UTF-8 encoded sequence of characters. Okay. The return iterator will return none once EOF is reached for this reader. Otherwise, each element yielded will be a result char E, where E may contain information about what IO error occurred. Okay, so here's the thing, right? It will only work with UTF-8 encoded stuff. And the byte order mark is something we have to decode at first. And this is valid to be existing at the beginning of each document according to the spec, or at the beginning of the stream. It must not change though. And the byte order mark is kind of something that is probably something you want to deal with directly or yourself. And I don't know how to handle this correctly. Is there any note about the bomb? To do bomb. Skip next token. Because in the moment, you can't really handle it if you're getting characters already. This needs byte-wise access, and that's the thing. So in a way, this serialized, even though probably a lot of code I could use, I would have to handle this a bit differently if I want to do it right, I guess. I would want to work. The thing is, I probably would want to work on bytes, maybe, so that I can use ASCII characters for the most part, because the Unicode stuff is something that for the most part doesn't matter, but the encoding does matter. And yeah, probably I would just use characters. Yeah, but that's gonna be very interesting. Look at all this code. It's amazing. It's 1,000, 2,000 lines. Okay, that's also some testing here. A lot of testing. Good. I like the macros that I use to kind of make the tests more feasible. I love that. Because I'm a bit lazy when it comes to macros because I'm afraid of them. Even though I should not be afraid of them. The only thing you have to get used to is the way you specify the cases here. But the rest, I think, is quite doable. Because it is, in fact, just normal Rust syntax with a little bit of special stuff. And simple replacement macros are easy to do anyway. So I shouldn't be afraid of that. But still, I kind of preferred to use generics wherever I can instead of macros. And so far, this worked out fine. Anyway, I think that's the gorgeous thing. For the most part, I will be able to use this code as great guidance because no matter what happens, I will have to do this. I will work on tokens, right? And that's that. Now I understand why the YAML still has strings, because these strings, they are part of the tokens anyway. Because, I mean, I was confronted with the same problem. I was lexing something, and if you get your characters from an iterator, then you never get access to the possibly underlying string anyway. So you can't work with spans or something. You can't just work with slices, basically. You need to allocate a string at some point, and there you can just hope for the most efficient way to allocate such a string as possible, like have an arena for strings or something. But for the first implementation, obviously you don't think about, I mean, you may think about it, but you will not use anything that increases your complexity. So I wouldn't do that either, right? So this is how that happens. Basically, you got these strings anyway. At least you have them in a buffer, and maybe from there you can efficiently spawn off a string. I don't know. Who cares? It's really the last thing you want to think about, because getting it to work right is the thing. Look at that. Yeah, I wouldn't even bother making these inline. Should the optimizer make it happen, huh? Let the optimizer do all the hard work. Anyway, is there a benchmark by any chance? Oh, that's the wrong one. My stuff doesn't work yet. Probably there's no benchmark anyway, but yeah, let's just do it in the background. We are 30 minutes in, should be long enough. Yeah, so this is super, I can only say this is probably the most interesting part. So here we have a scanner, which is the lexer that does all the hard work. And then the parser, in this case, just emits events, right? It has an event receiver that just gets these events with the tokens accordingly. And the parser probably is, well, it's easier to implement. Yeah. So the lexer does the hard work. And the parser then just has to properly interpret the grammar of YAML, which also it's context sensitive and it's probably not so easy. Parse node, look at that. But the awesome thing is that all this code is something that I can probably use relatively directly, even though it works differently from me. I get a callback that tells me that now I want to parse this, now I want to parse that, right? This is how that works. And I still need to figure out how it really wants to work when generic YAML documents are the destination of that. I think then deserialization will be more event-based like that. But if that's not the case, yeah, that's going to be totally interesting. Probably I implement two things, like one of this, something that is more event-based like this, because the underlying thing will be a YAML structure that you produce, and then one that kind of integrates nicely with callbacks you get during the from your deserializable structure. Speaking of which, let's look at serd real quick, and let's get the JSON value. JSON builder, I don't know, JSON D. Yeah, where's this JSON structure value here? There it is. So here the interesting thing is the serialization and deserialization implementation. So serialize. Serialize is simple. Deserialize, what happens there? Because the question is, how can you deserialize this thing into any document? So impl visitor. This is how that works. So you just get the callbacks in that case. And it creates the values accordingly. Right? But I wonder, how does it work with the normal structure? I never looked into this. So for YAML, I have See, now it uses the wrong one. I have my fixed rs, which allows me to see deserialize. Wrong. Deserialize. So how does it work? That's a complex structure. Let's have a look at the simple one. No, simpler. Still too difficult. I think at the end there will be something with deserialize. Serialize, deserialize. How does it work? Jesus Christ. Yeah. Yeah, see, I must say. So here we have 2 fields, right? Here we have 1 field. Let's look at the 1 field thing. So that's serialized. That's kind of understandable. But deserialize, I mean, we have an existing structure here that you want to set. And who's calling whom here? That's always my question. Apparently, if you can build a structure on the fly, then apparently the deserializer. Oh yeah, sure. The deserializer implementation needs to make calls to the visitor. Where D is, where's D? D is the deserializer, right? So this guy will then make the calls, right? And it will say, well, visit string. And this structure then needs to keep enough state to or this kind of built-in structure, this is why it's temporary, right? Needs to keep enough state to understand that, or what each call that it makes is supposed to correspond to. And either it works or it doesn't. So it just returns enumerations to have some sort of return value. Whereas the JSON value thingy will return itself, which probably the visitor can then possibly use. I don't know. Oh no, wait, maybe it uses itself. So visit, that's the deserialization code, visit map. See, so here's how the values are generated, just recursively. And this is how that works. And yeah, I think implementing this for the YAML structure is going to be the simple part after all, because it should be quite similar to this one here, even though that we will have a nicer interface maybe. Well, this is not necessarily a bad interface. I think it's pretty much the same. What was I thinking? Actually, I didn't know the JSON structure so very well. So probably we are kind of a mix of the best of both worlds here, I guess. But it's going to be very similar. So the yaml-rust implementation again. So the parser, damn it. Look at that. And that's going to be happening. And I'm kind of slow right now. I'm even slow with the serializer. But on the other hand, it's going to be quite feature complete and customizable. And that's the cool thing about it, I guess. But looking at all this code, I wonder how long it's going to take me to implement this. So this is the first. Look at that. It took him 10 days. 10 days to get from the initial commit to this one. 10 freaking days. So he is fast. I mean, I definitely don't work that much. And thanks to that much in the sense of I probably barely work 8 hours a day right now. But, I mean, maybe I do. I don't know. I didn't count them. But I also take it easy. But all this code, like 2,000, I mean, come on. That's 2,000 lines just here. Another 1,000, that's like 3,000 lines easily. Probably more with the test cases and stuff. Plus studies, you have to study this stuff. You have to know what you're getting into. And doing this in this time is totally amazing. What was the initial commit? Maybe he just did everything. kind of out of Git. And then, but I think he's like a genius. So look, that's the initial commit that has 1,000 lines. So quite some work has to be done, was done already. Oh no, wait, no. In total, it's 1,200 lines, but still, you know, lots of work. What's this, by the way? It is kind of Chinese. Interesting. For how Chinese it is, these guys look so European everywhere, huh? What is this about? NIPs and face recognition, object recognition, image search, image editing, and intelligent surveillance. Wow. So this is probably why he's so fast, because he is a freaking genius. So wait, is he? No, he wasn't Mr. Yang, huh? Mark Chen. Yeah. So there you go. This is why. So this guy is just real good. So that's okay then. Then I don't feel bad about it. Is there some Chen here? Nope. So he just works there without being listed. All right. So that is that. Awesome project. I think it will speed up the development of serde-yaml quite a bit. So thanks for letting me know. And yeah, thanks for watching and have a great time.